Okay. And how many people are .NET developers? Awesome. How many people here thought they were here for a SharePoint talk? No, okay, good. There's still time. You can go to the next one. Cool, okay, well, we're going to go ahead and get started. And instead, I'm just going to show a very simple scenario if you're an ASP.NET or a .NET developer to take advantage of, which is just go ahead and create a simple website. What would you like to call this? TechEd Australia, okay. Very creative. So we're going to go ahead here. We're creating a new website. I can choose different parts of the world that I want to run it at soon. Hopefully, I'll be able to pick Australia from that drop down. We have 2 new regions opening up here in Australia you'll be able to take advantage of. This website now, though, is created. I can drill into it. I can see some information about it. Since no one's actually deployed anything into it, I'm not seeing any charts on here because I don't actually have any usage. Let's go into Visual Studio and build a simple app to take advantage of it. Go ahead here and just say File, New Project. We'll call this TechEd AZ. Go ahead and I can create a web forms, MVC, web API, any type of backend I want. And I can then right-click, hit Publish. Inside Visual Studio, one of the things that we've enabled is some nice Azure integration. So you can actually directly inside the Publish dialog now, go ahead and just select your website that's in Azure that you want to deploy to. Then just go ahead and hit Publish. And literally in a matter of 20 or 30 seconds, your app should hopefully be deployed and live in the cloud. As you can see here, it's uploading. This is the very first time we're deploying this app, so it's uploading a whole bunch of assemblies in the bin directory. It's finished with that, and hopefully in about 5, 4, 3, 2, 1, it's done. And I now have a simple Hello World app running in the cloud on Azure. You saw end-to-end in about 2 minutes. We were able to create the site, create a project inside VS, right-click, deploy to it. So nice, simple Hello World there. And so as I scare you with more and more stuff and patterns as we kind of continue, I want to make sure you can always come back and say, wow, getting started is easy, because it is. And basically, if you're an ASP.NET developer, .NET developer today, the entry bar in order to start using the cloud is as simple as I just showed. But our goal of this talk, though, is to go much deeper. And so we're going to go much deeper than Hello World and really try to cover kind of some of the key development patterns and practices that you want to start picking up so that you can really build high-volume, real-world production apps. And so what I'm going to do is introduce about 13 patterns over this talk and the next one that kind of talk about kind of best practices that you can adopt. Some of them are practices, some of them are code, some of them are architecture principles that you can start integrating into your application. You don't have to use all of them, but most of them actually apply to a lot of applications and ultimately make you much more successful with the cloud. And so the first ones we're going to talk about in part 1 will be this session. And then if I get enough time, I might steal a little bit more content from the next session. Otherwise, then part 2 is when we're going to go super, super deep. And hopefully at the end of it, you'll leave with a better appreciation of how you can start taking advantage of the cloud, and again, how you can be really successful with it. So what I'm going to do here is not so much use Hello World as my case study. Instead, I'm going to use another app called the Quick Fixit app, which is a simple app. So I'm going to load it up here. It's based on the same ASP.NET UI template that I used for Hello World, but it's called Fixit. And what it lets you do is create a new Fixit request, or think of like a ticket for someone inside your organization if you want them to do something. And so I'm going to log in here, and I'm using just Forms Auth here, and now I can create a ticket. And I could say, clean my clothes. They smell. I could assign it to someone. And here is a picture of my dirty clothes. I can then create the Fixit request. It went ahead and entered it in the system. I could create another one here, and I could say, make bed, please. Assign it to someone. There's a picture of thing in action. Anyway, I can track to see what request I've opened. and I have opened other ones that have been fixed, that I've been testing. I can then log off, and let's say someone else wants to log in order to manage these things. Rather than use forms authentication, I'm going to enable single sign-on. I could use Google or Facebook in order to do single sign-on. In this case here, I'm going to use Active Directory and the organization's Active Directory account. So I'm going to log in as David. And now David can go ahead and see, here's all the tickets assigned to him. There is my bed, and he can mark it as fixed, and it disappears from his queue. There's my clean clothes, or dirty clothes. Don't worry, there's no underwear in there. There's, marked as fixed, there's no active tasks assigned to him. So very simple app here, simple workflow, where we can assign tickets. We got some data access, we got single sign-on, we've got UI, we've got deployment, we've got web, we've got async, we've got some storage, and a few other things along the way. But this is going to be the app we're going to work through all those different patterns, and we're going to kind of walk through how we built it, or how I built it, and some of the kind of techniques that I used along the way in order to make it reliable, make it secure, and build it in a cloud-friendly way that's really going to scale so that if I even threw 100,000 customers at it, I could actually survive that load and handle it well. And again, these are the kind of 13 patterns I kind of came up with that I'll walk, or 12 or 13 patterns that we'll walk through in order to illustrate the concepts. So pattern number one. One of the things you hear often in the cloud world is a good principle that you often hear also in the on-premises world, which is automate everything. How many people here automate everything they do with their development job? How many people here know that they're supposed to automate everything they do in their development job? Yeah. We don't always automate everything, but it's a good principle to keep in mind. And it's worth asking, why don't we always automate everything? Why do we right-click and hit publish instead of actually writing a script in order to do the deployment? Why do we kind of have a written checklist of 20 things to do in the database admin tool instead of automating it? Sometimes it's because we're lazy. Sometimes it's also because some things are just hard to automate. If you want to spin up a new virtual machine, if you want to configure all the things in IIS, if you want to actually provision that virtual machine in a data center with a load balancer, that can be hard. And you could do it, but there's no single source for how do you document it or how you actually script it all. And so we take the easy way out and we kind of have manual steps. Cool thing about the cloud is much more things can be automated. Because you're not actually running the core infrastructure and the servers, you can actually send REST calls to us, and we do a whole bunch of things for you. And so what that means is that you can actually now write scripts that do a lot more than what you could in an on-premise environment. And the other nice thing about the cloud world is it enables this sort of continuous mode where you can constantly be pushing out changes and getting feedback, and you're going to find you're going to want to do that in order to have a really nice development workflow and build the best-based applications you can. And kind of the thing you might have heard as a buzzword is this thing called DevOps, which is where you marry development and operations together. And ideally, you want to get into this nice cycle flow where you can develop, deploy, operate, and learn, and then repeat the process. Key things about this, if you want to get this nice DevOps workflow, is you need to be repeatable, you want it to be reliable, you want it to be predictable, and you want to be able to do things end-to-end with as low cycle time as possible. So from the point that you actually have an idea to the point it's in production and you're starting to learn from it, how do you have that be measured in minutes as opposed to days or weeks or years? And the key way to do that is through automation. So I showed you kind of in the hello world a little bit earlier when I went to the portal and I went create new website, and then I went into Visual Studio and I downloaded the publishing profile and I right-clicked and I hit publish. That's an example of a non-automated workflow. And it's fine to do that for learning, but in general I'd recommend is if you're going to really use the cloud, invest in actually writing scripts to do everything I just did so that you can always, again, do it in an automated way when you need to do it in a really fast and repeatable way that you know is always going to work. And so what I thought I'd do here is just kind of walk through a simple project, even before we get into our Fixit solution, that kind of illustrates a little bit about what I mean. So I called this Automated Hello World. So it's the same MVC4 project template that we created in a manual way. But one nice thing, or one change that I kind of did with this is you'll see that there's a little solution items folder at the top. Where I've basically checked in a couple of PowerShell scripts into my solution. And you can see here, I've got one called Create Azure Website and one called Deploy Azure Website DevBox. And what these are simple PowerShell scripts that look like so, which basically automate everything I need to do in order to stand up a new application environment for the project I'm working on. And so basically, the way to invoke this is just from a command that just says create Azure website, give it the name of the site, pick where in the world you want to run it, and then you can pass in a little database password if you want to. And then you can see there's a couple helper functions here, but conceptually, what I'm doing here is basically just automating everything that I just did and then some. So you can see here that I create a new website. So instead of just going through the portal and saying new website, I call a PowerShell command called new Azure website, where I pass in those locations. I'm also creating what's called a storage account, which we'll come to a little bit later on in the talk, where I can go ahead and store my images. And I'm creating a database and setting up a firewall rule for my database. And then the cool thing I'm doing is I'm specifying all the app settings parameters that I want to use for my website. So these are kind of secrets or connection strings, in the case of connection strings. And then all I do is just restart the website when I'm done. And then voila, I now have a website, a storage account, and a database fully automated. And I can literally just run from the command line. And within about 90 seconds, I can have everything I need in order to actually deploy this Fixit app up and running in a fully configured way. So that's kind of how I can create it, rather than kind of walk you through it, just sort of trust me, it works. The next thing I want to show, though, is once I've actually deployed this environment, or created this environment, how do I actually then deploy an app into it? So again, once I create it, I could right-click and hit publish every time like I have. And that works, again, for simple hello world scenarios, but it's going to break down once I start introducing data schema changes, or when I do storage, or when I do load balancer rules, or a variety of other things. And if I'm doing it manually, there's a chance one of any number of times that I'm going to screw up one of those steps, and I could have an inconsistent state. And so what I can do is instead, again, write another PowerShell script where I basically can just say deploy my project file. And you can see here what it's basically doing is building, using MS build, the actual project itself. So there's the MS build command. And then basically, I'm just publishing it to that website. And at the very end, I just go ahead and launch a browser that points to it. And so as an example here, if I go to automated hello world, what would you like the about page to say? Silence. In Oz. There we go. So we can go ahead and, again, I could right-click and deploy it, or because I have an automated script, I can just go ahead and, oops, my cursor's right, kick this off. This is, again, automating everything in terms of doing the building, the packaging, the diffing of the site. And what I should see in, again, about 5, 4, oh, there we go, is done. And so basically, my site's now deployed. We've even rebooted the site for kicks. That was all it took for me every time I make a change now in order to actually deploy it in a completely automated way from the command line. And the beauty here, again, now is I can make the script as complex or as simple as I want. If I want to do database schema changes, if I want to actually do more complex stuff, I can introduce that now in that workflow and know that every time I want to do a deployment, with one command, I can go ahead and kick it off, and I can make it completely repeatable every single time that I do it. So go ahead and invest, take a look at automation. One of the things that we're doing around the product to try to make this simpler, one is invest in actually having a bunch of really great scripts you can download, like the ones I showed, that just work for common scenarios. The other thing you're going to see us do increasingly in our dev tools is set it up so that we'll still have the nice right-click gesture commands, but rather than kind of just do it black magic behind the scenes, actually have the option where we can say, do you want us to generate a script for what we just did for you, and actually check it into your project, so you can actually easily generate with the same behaviors that you know inside the IDE. You can actually completely automate it, and again, have full flexibility. We hope we have the balance of both simple ease of use, but also, again, full power as you do it. So that's pattern one, highly recommend. You'll find the more you deploy, the more you're going to want it automated. And again, the fewer issues you're going to run into when you actually completely automate it. Pattern two, source control. Use it is kind of the first principle. I did this talk once and someone said, but I don't use source control. I said, okay, we'll just add that first bullet, use it. But a couple of things you want to think about then in a cloud world that are pretty important, which is how do you take source control and make it a core part of your workflow as you do your developments and as you kind of do your DevOps workflow. One key thing that we kind of evangelize in the cloud is treat your automation scripts as code. So I just talked about pattern 1, which is automate everything through scripts. Pattern 2 with source control is check those scripts in with the code. And the beauty there is now you can version your entire solution, both the actual code behind it, but also all of the automation scripts necessary in order to kick it off, deploy it, and run it. Make sure you parameterize all your automation scripts. Don't check in secrets or hard-coded locations. And make sure that as you kind of structure your source control, that you really do it in a way that you can enable kind of a clean DevOps workflow. What do I mean by that? One of the common things that in a cloud world that you're often wanting to do is be able to kind of ship features fast, but also be able to react to feedback much faster than you would necessarily in a product package-based world. And one of the things you want to think about as you kind of start a project in the cloud world is can you structure your source branches to enable that? This is a kind of a common, for very large teams, often to kind of do a pattern here where they have a master branch, where in the master branch you basically have the source control for what is live in current production. So this is actually what is live inside the cloud. And then they might have a staging branch, which is basically the bits that are about to be live, that you're doing final testing. And then have a development branch where you're actually doing your feature development and iterating on it for development. If you have a small team or just yourself, just have a simple development branch. But if you have a larger team, you might also have sub-branches where you have different developers working on different features. And basically the workflow, check it into development, put it into staging, put it into master, and know what each branch's use and kind of value is for. One thing that's nice thing is, can you make a quick fix? And so one of the things to think about again in the cloud world is when someone reports there's an issue, how quickly can you react to it? One thing that's nice is can you go ahead and easily with your branching structure create a branch where you can do a hot fix or a quick fix without having to worry about a whole bunch of features that are checked in. And so a nice thing about kind of a structure like this is it makes it really easy for you to say, let me start with staging or just start with master. Take that version of the source code. I know that master is what's in production. Make that quick fix, check it in, blast it out, and you can sometimes literally in a matter of minutes have a fix for a live production issue that your customers are reporting. But if you just have one source tree or you have features and you have the live code all intermixed, you're going to find it much harder, and that time-consuming effort in order to finally test it is going to cost you when you have an issue or a site's down. How many people here have a source control system set up like this? Cool, good. You're on your way. You can do this with any source control technology. One thing that people often are turning to is kind of a distributed source control based model, something like Git or Mercurial or other kind of techniques, partly because it allows you to very easily create branches on the fly, and it allows you to kind of work with different branches in a fairly agile, flexible way. How many people here are using Git? Cool. How many people are using Mercurial? People are using TFS. Great. So one of the things you can do with the new version of TFS, the new version of Visual Studio, is we're actually adding Git support to TFS. And so what that means is you can use TFS not only as your source control system, using the traditional TFS model, along with your project and build and test management, but you can also, if you want to, alternatively use Git and get distributed source control on your TFS system. So you can still use TFS for project work items, for testing, for builds. But if you want to, you can use Git then as your source control mechanism. And with the new version of Visual Studio, there's pretty nice Git tooling support that's actually built in the Solution Explorer that lets you actually work with things. So for example, I have this project checked in under source control. We changed this to be silence in Oz. I can go ahead and commit and say, change string. And what you're seeing here on the right is some of the new built-in Git tooling support. And so, this change was now just checked in with Git, all again directly within VS. If I want to and create a new branch, I go ahead and we'll call it feature 2. And I just created a new branch inside my Git repository for this feature 2 branch. I could change the silence, or let's say noise, in Oz. and I could go ahead and check this in. New string. There we go. I now have 2 changes, and you can see here I can basically flip between my branches and see my source code changing in real time as I actually do that. And so it makes it really easy for me to basically create a branch, work on a fix, go back to my master branch, compare them. If I wanted to, I could go ahead and, oops, let me go back to the other branch. If I want to go back, say, to my feature branch and compare it to master, I could go ahead and view the history or compare the two. If I make another change there, I could go ahead, compare with modified, full diffing support is now included. Again, makes it really easy for you to go ahead and manage all your different branches, make changes, and again, iterate much faster. Way that I'm using for this Fixit application, there's a couple different ways you can deploy a web app. You can deploy it inside what we call a virtual machine, where you manage and configure IIS, and you own everything inside that virtual machine. We have a programming model we call cloud services, which is kind of our historical PaaS-based programming model. It's very, very powerful and lets you build a variety of different types of apps. We also have what are called websites, which is optimized for building web-based applications. That's what we created when I went ahead into the portal and created a website and deployed to, and that's what, when I hit that automation script, I was actually deploying through. And it makes it, again, really easy for you to go ahead and build a web front end that can scale from 1 to many different web servers that you can deploy to. So what I want to do here is just spend a little bit of time walking through architecturally what happens when you use it and some of the benefits it provides, and then we'll kind of walk through how we're actually using it with this Fixit application. So what I have is with Windows Azure websites, it's backed by what's called a service. So it's a service that we run where we actually manage all the machines for you, so we patch them automatically for you. You don't have to manually TSN or install a patch or do anything. And as part of this service, there's several kind of logical different components that are built in. One are the actual virtual machines running IIS, where your code's going to run, but also load balancers and a deployment service that's going to handle some of the other operations for the site as well. And so when you're a developer and you go into the portal or you use Visual Studio and you want to deploy an app, basically you fire a command to our website service, to what's called a deployment service. It's now going to go ahead and take your app code and deploy it on some virtual machines that it has on hot standby that already have IIS loaded. Then your app is basically loaded within them, at which point customers can go ahead, type in the URL of your application. The DNS will come to us. We then have some built-in load balancers that are kind of smart load balancers standing in front of those web servers, and they'll automatically route that request to your application. You send back HTML, the person sees it. So very simple conceptual model. What's nice about the website model is if you send a lot of requests, the load balancers are smart. We can actually fault in new load balancers on demand, and they can distribute the load across any number of virtual machines that are actually running your web application behind the scenes. What's also nice about the website model is that if you ever have a failure of a machine or you have unhealthy code running inside that virtual machine, the model's smart enough that it'll actually spin up a new virtual machine automatically, and the load balancers will immediately start sending traffic to it, and they'll no longer send traffic to the unhealthy machine. And that firing up the new instance of the virtual machine typically happens in a matter of a few seconds. So you don't have downtime, and your app can be very agile in terms of how it handles load and how it responds to kind of external events that are happening to it. And so that's kind of nicely all built into the system. And so when I created that website and deployed something to it in the hello world, that's all running on top of this infrastructure, again, which is really powerful. Wherever possible, scale out your data by partitioning it. We have lots of big machines that you can rent within Azure so that you can actually scale up to a certain degree, but there's always going to be limits in terms of how high you can scale up in terms of data capacity. And this is true for all cloud providers. What you really want to try to do is if you think you're going to have lots and lots of volume, design up front to scale out by partitioning the data into different chunks so that you can just keep adding servers and actually horizontally scale out your infrastructure in kind of a sharded way. And so what I thought I'd just walk through a couple patterns here, and then in the app, we're going to go ahead and update the app in order to take advantage of them. So there's a couple different ways that you can actually partition your data. And right here, I'm just using sort of a simple table just to kind of, since this is a nomenclature a lot of people coming from a relational model know to think about. I'm going to walk through kind of two different patterns and then a hybrid pattern you can use. This first pattern is what I'm calling vertical partitioning, where I have a bunch of rows of users and I got a bunch of columns. What you can do is, rather than stick this all in one data store, with vertical partitioning, you can pick some subset of the columns and store it in one data store, and then you can have some subset of the other columns and store them in another data store. So for example, here I could say, hey, things like last name, email, username, we're going to stick this in a SQL database. And things like a picture or a thumbnail picture of the person, I'm going to stick in a blob store. And the benefit there is blobs are really good at storing lots and lots of big-sized data in an unstructured way. SQL database is really good on querying. This is an example, again, of vertical partitioning. Another approach, which probably people have heard the term sharding before, is where you actually partition it based on kind of a horizontal pattern. So instead of partitioning by rows, instead go ahead and partition by columns, where I might go ahead and say, hey, people that have a last name that starts with A, go to one database. People that have a last name that starts with C, go to another database. M, go to another database. Z goes to another database. And you're basically partitioning your data by scattering it across multiple different data stores, depending on some key or some value. I'll warn you, that's a very naive access pattern. Don't do it that way, because it turns out a lot more people have last names that start with C than they do with Z, typically, in most parts of the world. And so you can end up, if you have a sort of naive pattern, you might still end up sending 80% of your users to one data store. And so, there's a variety of more advanced techniques, and I'll link to some of them at the end in the appendix, that you can use if you want to take advantage of this type of approach. But conceptually, this is where you're splitting your rows logically across multiple data stores. And then the other approach you can then do is, and what most big sites end up doing, is some combination of the two, where you vertically partition some of your data and you horizontally partition some of your data, and you can actually distribute it across multiple different data stores using whatever different pattern that you want within it and whatever key value pattern that you want. And so when you hear about these large sites, whether it's Facebook, whether it's Twitter, whether it's Office 365, they tend to be using some combination of all of these patterns in order to partition their data up front. Key lesson I'll mention, it's a lot easier to partition your data before you actually have users jamming data into it than it is once you go live. And there's folks here from our advisory team, I noticed in the audience, they basically get called about once a week from a big customer that went, oh my God, we've got a problem. Our app is lighting up, we're getting all these users, and we just realized we're gonna die in about 2 weeks when our data store is filled up. And we basically fly these gentlemen around the world, and they kind of parachute in and they help rewrite and re-architect. Most times it ends in a happy way, but sometimes if you've got a really busy app with a lot of usage on it, it's almost impossible to partition without some downtime. And often, if your business logic is scattered all over the place, it can be really hard to partition, period, once you actually have the app built. So wherever possible, think about this up front. Remember those 3 V's, and design your application as you're writing the code to be partitioned, and you'll find it's really, really easy. Even if you're not entirely sure that your app is going to scale out big, you can always go ahead and take advantage of this approach, hash it and partition it this way, but stick it all in one database, and then just change the hash key later so that you actually partition into more databases, but at least have the architecture set up so that you can do that at a later point if you go big. So we talked a little about data. Let's now move into kind of sort of some of the more fun, advanced stuff, which is how do you survive failure? So once you have that insight, a couple things you're going to discover. Failures are happening. So the great thing about the sort of multiple phases of the cloud thing is step one is realizing, oh my God, failures are happening all over the place. That's better than not knowing there's failures happening all over the place. Step two is let's handle those failures. The first type of failure we're going to talk about is something called transient faults. These are probably the most frequent types of things you need to think about in any distributed system. This is true even in an on-premise environment, but also in the cloud, which is temporary glitches. The network goes down, the server has a blip, capacity is overwhelmed on a specific service. It might only be for a couple seconds, it might be for a couple minutes, it might be for a couple hours. And one of the things you want to think about inside your application is how do you gracefully handle these as opposed to simply throwing back an error that's happening to the user. There's a couple different ways that you could do it. One of them that we recommend for anything where you're talking to a dependency. So anytime you talk to blob storage, anytime you talk to SQL, anytime you talk to Twitter, is have what's called smart retry logic. So in other words, the pattern is try to access it, try to do your operation. If it fails, retry it. And if it fails again, retry it. Now, you want to be smart about it because you don't want to just continually hammer and retry it. So what you want to typically do is do what's called an exponential back-off logic. So this is kind of a simple pattern that Patterns and Practices library has. Basically, it says, in this case here, try doing the database connection operation 3 times, and then back off up to 5 seconds if there's a failure. And it will do the automatic logic to kind of figure out, I'll try once, and then I'll try again, maybe 3 or 4 seconds, and then I'll try again after that, up to whatever threshold that you set. And that way, if the database closes the connection or terminates the connection, or a load balancer in between you and the database does it for you automatically, you can basically survive and handle it. The nice thing about EF6 is it's adding this support built into EF. And so all you need to do is basically just add 1 line of code, or it's actually 3 lines of code, into your EF configuration class. And what this then, you can do the same kind of retry max delay policies where you can say, hey, if the underlying connection in EF gets blown apart, recreate it using the state you already have and try it up to 5 seconds. After 5 seconds, then throw an exception. But this kind of ability to kind of do this back-off logic in a smart way will probably insulate you through lots and lots of different types of errors that might happen in the underlying system. One reason to also think about this in a cloud world is oftentimes with a on-premise environment, you've got a web app and a database that are sitting next to each other in a rack. You typically don't have that many network problems because you're typically just talking to each other through the same network router. In a cloud world, your database and your web tier might be going through 1 or 2 network hops. We try to optimize it as much as possible. But that's why you want to think more about these types of transient errors. You're going to see more of these types of transient errors in the cloud world is because there's more network hops, more network cycles, and you will occasionally see a network load balancer chop a connection for a variety of reasons. And so again, these types of little tricks that you can add into your code will dramatically improve your reliability. I'm not going to show it just because I basically showed the code, but that would basically just, the demo would be showing this 3 lines of code inside the app and how I'm handling it. One thing to be mindful of, which is, and the reason I kind of said exponential backoff, is you want to, and having a max threshold, is you want to be really, really careful when a thing that you depend on starts to back up, that you don't simply throw more and more requests at it. If a service is overwhelmed because it's having a load issue or because it's having a problem with reliability, it doesn't help for you to send another 10,000 requests to it over the next 2 seconds because it just typically makes it more overwhelmed and makes it harder to catch up. Also, likewise, inside your application, if you start queuing up your users and you try to indefinitely to keep trying to make that one request work, what ends up happening is your users that get stuck behind the person that's queued just get a great degraded experience. And oftentimes what's better is, try once or twice and then give up and get out of the queue. Anyone here ever been stuck on a flight that got canceled? I have. And I'm hoping to not tonight. But one of the things that you sometimes, that's very frustrating as a passenger is when they say, hey, I'm sorry your flight was canceled. And you go, great, am I on the next flight? And they say, well, not really, because the next flight is booked. But you're on the midnight flight. And you're like, wow, man, why? Bump the person on the 4 o'clock flight. Why do I get bumped at noon? Well, it's because if they bump the person on the 4 o'clock flight, then the person on the 4 o'clock flight then bumps the person on the 8 o'clock flight, and the person on the 8 o'clock flight then bumps the person on the midnight flight, and then everyone's upset. It's better to actually make the people on the noon flight that got canceled unhappy, and then let all the other planes go through, and then figure out a way to integrate them back in there. And that's similar to this back-off logic here, which is if an HTTP request or web page request is going to fail, it's better sometimes to fail fast and have the user just hit refresh as opposed to making the next 100 users that are trying to hit that page have a slower experience. And that's sort of this back-off. I'll give you an example of, anyone remember when Skype went down a couple Christmases ago? It was actually before Microsoft bought them, I'll point out. But they had a pretty bad outage in the holidays. And the guy who runs Skype and I were at a dinner and we were talking about changing cloud war stories and terrible things that have happened. And one of them he talked about was this Christmas outage. And basically what ended up happening was the Skype clients, basically they had an issue in Skype. And the way the Skype clients were designed is they automatically retry. And it was Christmas, so there were lots of users that were online. And what ended up happening was they had an outage. All 10 million, 15 million people using Skype, backed off, and then retried again. And then Skype was overwhelmed, they couldn't handle it, so they backed off and they retried again, and more people got online, and more people got online. And basically they had a giant denial of service attack from their own customers. And the original issue, they could have come back up, but because all of these people were constantly pounding it, they literally had to change the network routing tables so they could bring the Skype service up and then gracefully bring people online, because they were just having these sort of waves of people attacking their own, the waves of their own app with their own customers attacking their own service. And so that's why you want to think about that and be careful about it. Other kind of patterns that you can handle. Distributed caching. So the exponential backoff and the kind of gradual retry will handle temporary glitches. And so if you have a data store in particular, make sure you do that exponential, transient failure handling. Having said that, though, you're still going to run into issues where either the data might be gone for more than a few seconds, and so it's more than a transient fault, it's more of a persistent failure. And also sometimes you don't actually need to hit the data store on every request anyway, and that's where caching can come into play. It can help you with both of those two scenarios. Sometimes it's okay if you're surfacing weather data or the latest boat racing results from the America's Cup. You guys won, by the way. Again. You don't actually, every time someone brings up their app to say, hey, did they win? You don't really need to go to San Francisco in order to pull the results. You really want to cache it. And you might want to update it every second. You might want to update it every minute. You don't actually have to, it doesn't really need to be, immediately consistent. And that's where caching come into play. And then the beauty is if, for example, the service that's exposing the America Cup's data goes down, if you have a cached copy of the data, you can actually implement a switch inside your app and say, hey, you know what? I'm supposed to update it every minute, but for some reason the service isn't available. You know what? I'm just going to wait a couple minutes to upload it until it is available, and my users will probably never figure it out. Or they'll certainly appreciate a cached version of the data more than, hey, we have no idea. So one of the things you can do is take advantage of the new Windows Azure Cache service in order to implement this. It's a new service we just went live with last Wednesday. And it basically gives you a high throughput, low latency distributed cache. It is all in memory, the data, so it's not written to disk. If you have like petabytes of things you want to cache, you might want to use a blob storage system to cache it that way instead. The beauty about the in-memory cache, though, is it's lightning fast. Basically, if you retrieve something from the cache, it takes about 1 millisecond end to end. That includes all the network time back and forth from the web tier or your app tier to the cache and back, which is pretty fast. And when you put something in, it's about 1.2 milliseconds. So it's very, very fast. And it's designed to scale out across multiple nodes. So you can go from 128 megs of cache all the way up to 150 gigs per cache instance. Creating it's really easy. You go to the portal now. You do need to sign up for the preview. And then you go to the portal and you can say, quick create, give it a name, point it in some region, pick the size you want. It's created. It actually takes about 4 minutes or 5 minutes to do this, but imagine it was instantaneous. And then basically you have a dashboard where you can see information about different settings. You can then go ahead and have one giant memory cache, or you could also have what are called partitions, and you can set up different policy rules based on each partition. So you might have some data that expires, some data that never expires, and you have different time frames for each. You can also, and then basically you can get a connection string from it. You then go into VS, you add a NuGet package for your cache library, paste in the connection string information that you got from the portal in your web.config file, and then basically this is all the code you need to write in order to save and retrieve something from the cache. And so basically you create a new cache API, you put a key value pair, you get the key back and you get the value back. And that's basically persisting and retrieving it from that in-memory data source. You can then monitor it so you can see how much memory you're using, how many times you're hitting it, how much compute's there, and then you can scale up or scale down the amount of cache if you need more instances or you need more memory. You can do that all dynamically. And when you scale up and scale down, you don't lose your cache. Well, if you scale down and you have 150 gigs of data and you scale it to 128, you're going to lose up to 100, you're only going to keep 128 megs of your cache. But if you need to scale up your cache, we're pretty smart about adding capacity and not losing the actual already cached items, which is a nice feature that no one else has. And so basically what this means is you can now have your website VMs with auto-scale going against that cache. You could start off, say, with 24 gigs of cache. If you know, hey, we're filling it up, let's add another 48 gigs. Again, you can scale it out. And all of those web servers on all those different VMs can all access the same cache. And so the benefit there is if one VM caches it, the other VMs all have access to it. And that's what makes it distributed. And it basically gives you a way you can scale and cache data across all the apps, or all of the VMs and instances within your application. If you ever use the ASP.NET in-memory cache, the cache API, that's an example of an in-VM cache. That's a great cache, but it would basically mean the data is only stored once inside each of those VMs, and so each VM would have its own cache copy. With a distributed cache, they all have access to it. We're also smart so that if a VM goes down or needs to be upgraded for patching, we can migrate the cached content to the other nodes and then add a new node into it. So we do all the management for you in the back end as well. A couple of cool things you can do with caching as a strategy and as a pattern. A lot of people implement what's called an on-demand cache-aside pattern. This is where your web tier hits the database, grabs the data, and then when it gets it back says, hey, let me cache it, and the next time it checks the cache before it hits the database. If you've ever used kind of like a content management system, like if you use a blog or you do most CMS systems, it's typically using this on-demand cache-aside strategy. So the first time you hit your blog, it hits the database. The next user that hits it hits the cache content. And then after 10 minutes, it resets, and the next guy gets it from the database. And so it's a good strategy you can go ahead and use. Another approach you can use, though, is you can basically say your web tier never hits the underlying data source. So if I was building an app in New Zealand for the America's Cup results, I would probably not have the mobile apps hit San Francisco directly because there's enough people here that care about racing, and since you're going to win it, you might care even more. And so, knowing that, hey, 5 million people might all, with a short window of time, be pounding to see the result race, I don't want to use the cache-aside strategy. What I might instead do is say, I'm going to use a background data push, where I'm going to say all the web tier and all the mobile clients are going to hit the cache always and only, and then I'm going to have a background service that's just running that once a minute hits San Francisco, gets the results, and then pushes the results in the cache. And that way your web tier is always going against the cache. And that means I don't have to ever worry about thousands or millions of users and ever hitting my backend data source. The other benefit about that approach is if San Francisco ever has a problem reporting the data, the users are still seeing the latest copy in the cache. And so one challenge with the on-demand cache-aside strategy is if the cache expires and then everyone hits it, if for whatever reason that service isn't available, you'll have outages or you put a lot of load on there. And then some people also use a pattern called circuit breaker. This is not exclusive to the cache. There's other circuit breaker patterns. But it basically says, hey, if I detect something going wrong in my app, let's just fail over to the cached version. If you've ever used Twitter and you ever see like, hey, I can't go back in time, and it says, hey, sorry, you can only see your top 15 cached items in your Twitter feed. That's an improvement over what they did a couple years ago when Twitter went down. You had the fail whale. Remember that? That was really frustrating. It was cute the first time, and it was really frustrating after that. The nice thing about their approach now is they have a circuit breaker, and they basically discover when they're having an issue, they basically just flip a switch, and the experience gets degraded automatically. It still shows your last 15 items. It still shows a bunch of functionality, but they've effectively turned off a bunch of things, and they've gone into cached mode until the service is healthy again, and then they flip the circuit breaker back, and the system gets back healthy. And so that's another pattern you can use with caching that can end up improving your experience. Anytime your users share a lot of content or where the content doesn't change frequently, cache it would be my top level guidance. It'll make your apps a lot faster, and you'll have a much more reliable system. So caching is really good when you have information that you want to have available even when the underlying service is having issues. So it's great for any read-only pattern. You might be asking, but what about write patterns? So this Fixit app, it's great. I can cache my list of items, but what happens if someone wants to come and enter a new Fixit task in the system? How can I do that? And this next pattern, this final pattern, is called the queue-centric work pattern, and it can help with it. Basically, the idea behind the queue-centric pattern is enable more loose coupling within your architecture so that you don't have to do synchronous tasks every time something happens. Instead, what you do is you create what's called a message, you stick it on a queue, and then you respond immediately to your user, and then something picks it off from the queue and then does processing with it later. It's really useful for anything that's time-consuming. It's really useful if you have something that's resource-intensive. It's really useful if you're relying on an external service that might not always be available. And it's really useful if you have a sudden load burst. So if you have lots of people wanting you to do something immediately, queuing's a really good way. You can do what's called rate leveling so that you can kind of handle that and then catch up over time. So what does this look like? Let's take our Fixit app, and we'll kind of illustrate it. Right now, we have a Fixit web server talking to our database. This works. But what happens, and we show success as soon as you enter a Fixit task. But what happens when the database goes down? Well, the web server's offline. You can no longer add Fixit tasks. And that might be okay for a small application. But if you got a lot of users, they're going to be really annoyed when they can't enter Fixits, and they're going to go to someone else's service. Another approach you can do is this loosely coupled approach, where instead of the Fixit web server entering a Fixit task immediately into the database when someone enters it, they instead stick it on what's called a task queue. And so they create a little message in JSON, serialize their .NET object to it, stick it in the queue, and then they show success immediately to the user. And so it's never even reached the database before they're telling the user, hey, thank you for your order, we're working on it now. You might be thinking, hey, that's cheating. Yes, and your users will be thankful for it. If you've ever bought something on Amazon.com or Amazon.co.z or any e-commerce service, and you go to checkout and you go check out and it says, hey, your order's on the way, they just cheated too. This is exactly what they're doing. They didn't really talk to Visa, they didn't really schedule it, they didn't really pull it off the shelf and actually box it all up in that fraction of a second. Instead, they just stuck a message in the queue and said, thank you, it's on its way. And then in the background, they have something that pulls it from the queue, processes it, and updates the database. And now, if the database goes down or the queue listener goes down, you can still be firing orders and messages into your system. Your users are still happy. They're going, hey, this thing is so reliable, it's never down. And you're panicking, oh my God. But when it comes back up, you're going to be able to process those messages, and the user will never know, hopefully, that there was an issue. It's also then useful if suddenly a whole bunch of people show up and they say, hey, I want to order this thing right now. So think of this like the social networking burst or an advertisement on the TV. Everyone goes to the website and wants to buy that thing, or they want to order it or get notified. The beauty is you can now have autoscale spin up as many web services as possible. They're all taking the order, sticking it in the queue. And then your background listeners can slowly catch up. And so you can handle that sudden massive burst because you're not actually doing the expensive work until later. And they can do it more sequentially, and they can actually process it as they have time. A really cool feature about autoscale that we have built into Azure is you can make autoscale work either CPU-based, or we also let you do it by queue length. And so you could actually have worker roles or VMs in the background automatically get spun up as your queue size increases above a certain threshold. And so we can automatically start adding machines to help you catch up on the background if it's a sustained burst. So you might think, okay, this sounds cool, but how do we modify our existing Fixit task scenario to use queues? So remember, this is the scenario. We enter data, we enter a photo, we upload it, we show success. The way it's implemented today, our web tier is directly talking to the database, inserting a Fixit task. What we do in the future is we just replace that one line of code, and instead we fire a message to our Fixit queue manager. All this is doing here is basically just connecting to our storage account, just like we did with Blob. In this case here, we're referencing a Fixit's queue. And I basically just serialize that EF POCO object into JSON, and I post it into the queue. Sticks it in the queue, and then on the background, I have another VM that's just going to basically pull forever, pulling things off the queue, deserializing it back into that object. And then notice we're using the exact same Fixit task repository that we were using before to save it into the database. And so all we did was basically decoupled that one line of code that create Fixit, put it in a background role, and then passed it through a queue. And that's basically all we need to do. And once we do that, we get a lot more resiliency. And so now, even if our database is down, we can still take Fixit tasks. and show success to our customer. It also means that because we've now decoupled showing the success from the actual processing of the message, if we wanted to add more logic, so for example, instead of just saving it to the database, I wanted to actually figure out who should process it inside my organization. Or if I wanted to send SMS messages to notify the person if it was an urgent request, I could start to add that logic in the queue listener without blocking the web tier at all. And you might say, well, what if the SMS service is down? Well, the beautiful thing is I can even do more custom workflows where I could do long-lived operations where I could say, hey, if the SMS system is down, just queue it up and keep retrying until it comes back up and then go to the next step. And so you can really kind of start to orchestrate much more reliable systems by using this queue pattern and then do it for either short or long-term services. So what is our SLA now? Just thinking about this queue service, forget caching for a second. Previously, we had 99.75 because this is for the create fixit request scenario. So this is not read, this is only write. So this is when I sign up to go and create a new fixit. Previously, we needed all three of these services to be healthy, 99.75. Now that we have a queue, we only have two services because queues are part of the storage service. So I'm not adding a new service, it's actually part of the same storage service. And so now we're back up to 99.85. And so again, even if the database is down, my app is doing okay. Now you might say, hey, 99.85 is still, 12 minutes a month of downtime, or I think that still seems too much. How can we make it more reliable? Well, here's the cool thing. Storage accounts can be scattered across all Azure regions. So what I could do to actually make this 99.95 is I simply have two storage accounts. And so if my primary queue listener is down, I basically go to the backup one. And I literally just inside my code say, hey, try sending here. If it fails, go here. And then I now have two storage that are independent of each other. And suddenly now I'm probably close to perfect on that SLA, at which point my overall SLA is now just gated by my web tier, which is 99.95. And if I wanted to be even fancier, I could then have two instances of my web tier running in the two regions that are independent of each other. And I could use what's called a traffic manager component, so I could actually automatically fail over if my web tier goes down, at which point my app is almost 100% SLA. It's not really 100% SLA. It's 99 close to that 6.9 SLA that we have there. And so, basically it's by starting to use these kind of components, thinking about the telemetry, looking at what's failing, and sort of decoupling it in this loosely coupled way, I can start to add significantly more reliability within my system while still being very cost effective and start scaling it out. And so, as you start doing, things that are more stateful, so for example, there are some operations that are harder to scale. I don't want to make it sound like this is just trivial to start getting to 6.9s, because it's not. But hopefully these patterns that you're seeing here, you can start to see how, as you start thinking through them, you can start hardening the system and start handling more types of failures and sort of build kind of reliability across them. There's a reason why for Azure we always try to have two regions inside each geopolitical boundary. So when we come to Australia, we'll have two, one in New South Wales and one in Queensland, is so that for you inside New Zealand, you can access both of them with good latency, and you can do that failover, and you can actually have your services distributed across the two in order to do these types of tricks and drive your SLAs up. Cloud services, I'm just going to briefly mention, is one way you can package up these apps in order to actually have both your web and back-end tier set up together.